Hello, good day everyone. This is Professor Roger Flores of the Department of Electrical Engineering, the professor of this subject EE30, Electrical Engineering Utilities. Today we are going to discuss Chapter 1, and this is entitled Electricity Theory. No? So here we are going to discuss the brief history of the electricity and how electricity is produced and other theories that involve the production of electricity. So to start with, we have this chapter 1.1, History of Electricity. Okay, so let us start with 600 BC, 600 before Christ, and it is said, or it was said, that there was a Greek mathematician named Thales or Thales, who were able to document or made a documentation on static electricity. Okay, so through rubbing an amber with a piece of wool or fur. So, if you are not so familiar with what we call as amber, this amber is a solid material. It is from the juice or juices of the bark of a tree, and then for a period of time, it will become solid, no? So, that is why if it will be rubbed in a wool or a fur. So when we see a woolen material or a fur, something like a hairy, yung mayroong mga parabang mga buhok, no? So material, then it will produce static electricity. Okay, on 1600, William Gilbert, an English scientist, coined the term electricity from the Latin electricus, no? So electricus, which means produced from other friction. It is due to rubbing and friction, no? So the idea of Thales was continued by William Gilbert, and electricus means it is a Latin word. It means produced from amber friction, no? And a Greek term elector, which means beaming sun. Okay, so that is how electricity started, no? In 1660, another German experimenter, Otto von Guericke, or Guericke, built the first electric generating machine. Okay, he was able to create an electric generating machine. Then later on, 1746, German inventor Ewald George von Kleist and Dutch physicist Peter van Maschenbroek invented an electric storage or an electrical storage device. Okay, so a device that will store energy. Okay, so it is coated inside and outside. It is something like a jar, no? That store electrical energy. Okay, on 1747, an American inventor and statesman in the person of Benjamin Franklin. I think you are familiar with this person, and suggested that the two types of electric forces. Okay, so there is two types of electric forces, and these forces may be called as attractive force or repulsive force. When we say there is an attraction between the two charged material, if there is an attraction, then it will produce an attractive force. And of course, if it repel each other, then we have this what we call as repulsive force, or it is from the positive and negative charges, no? Which we will discuss that one later. Okay, one of the famous experiment of Benjamin Franklin was the Kite Experiment, no? So you might hear this one already. And this kite, when was it was uh, it was stricken by lightning, and then it produces, or Benjamin Franklin felt that there is electricity uh, flowing in the cable or the cord that is used in that kite, no. So he was able to conclude that there is such a term, or such a phenomenon called electricity and lightning. Okay, so in 1786, there we have Professor Luigi Galvani. He is an Italian anatomy professor that observed that discharged static electricity made a dead frog's leg twitch, which the leg serves as an electrolyte, and the muscles. Okay, so the leg serves as an electrolyte, and the muscles as circuit and indicator. Okay, so he found out, because he was an anatomy professor. He experimented maybe the frog, no. So that he said that the leg of the frog twitch because of this static electricity that uses the nerve. Okay, so uses the nerve as its or the leg serves as an electrolyte, and the muscles as a circuit, which indicates that there is a what we call as a circuit. Okay, so we have also Alessandro Volta. Okay, so we have this Alessandro Volta and voltaic pile, or electric cell or battery. Okay, so that is the contribution of Alessandro Volta, and that is why, because of this contribution, that he was able to make this battery. Okay, he was able to make the battery, and then because of that contribution, then the unit of the voltage was used, or is used as his family name is used as the unit of the voltage. Okay, so that it was 1786. Okay, so in 1820, okay, certain Danish physicist Hans Christian Orsted, okay, discovered that magnetic field surrounds a current carrying wire. So, like for example, no, we have this current. There is a conductor. So this is the conductor. Then this conductor has a current that flow in it, no. So there is what we call as magnetic field around this conductor. So it depends upon the direction of the current. Okay, so more or less it's if we know the direction of the current, then we will be able to determine the direction of that magnetic field. It is just by using the right hand rule, no. Okay, so if this is your right, or I mean this is your right, no. So if this is the direction of your current, okay, then the direction of the magnetic field is in this direction. Okay, so going downward, so we have this direction. So according to Orsted, that there is the magnetic field if we have this current carrying conductor or current carrying wire. In 1882, Andre Marie Ampere observed that a coil of wires act as a magnetic, or as a magnet, when there is an electric current. So coil, talking about coil of a wire, this is many turns. It is a wire of having many turns. And this many turns of wire, if there is a current that will flow, then it will produce a magnet. And that magnet, we call that one as electromagnet. Okay, so it is different from a normal magnet, because that normal magnet may be from a stone, no? And you cannot vary that the strength of that magnet or the amount of magnetic field. But when it comes to electromagnetic or electromagnets, then you will be able to uh, vary the magnetic field, the magnitude, or we call that one as the density of the magnetic field, by of course changing the number of turns, or changing the amount of the current that will flow in that coil, or that turns of wire. We have this Dominic Francois Jane Arago. Okay, so invented the electromagnet. Okay, so yun na po yung sinabi natin kanina na electromagnet. So it is called electromagnet because the one of the element to produce this electromagnet is using this electricity. Okay, so we have this 1822, we have this Joseph Henry. Okay, he demonstrated an electromagnetic device that can lift over 1,000 pounds. Okay, so we have this electromagnetic device that can be able to lift a material which will have 1,000 of pounds. Okay, so yung medyo mabibigat na yung lift up niya, no? So it was discovered or demonstrated by Joseph Henry. So later on, this Henry is used as a unit of one of the component of this electricity. Okay, in 1831, we have this Michael Faraday, and he was able to develop a crude electric motor. Okay, so we have Michael Faraday produced a machine that will able to or using electricity, it will rotate. And this electric motor this time has several or various application. Okay, so we have various application of this electric motor this time, that even your electric fan, that even your water pump, or your escalator, elevator, and so on. This will be run, or we will be using electric motor to let this work out. No, then Michael Faraday and this Joseph Henry invented an electric generator, no, that power the motor. Okay, so this electric generator, of course, this generator is a machine that produced electricity, or simply this is a machine that converts mechanical power to electrical power, or mechanical energy to electrical energy, while motor is a machine that converts electrical energy to mechanical energy. So again, electric generator was invented by Michael Faraday together with Joseph Henry. Okay, so in 1831, Morse or Samuel Morse used this electromagnetic telegraph. Okay, so and used this code of electrical impulses, no? So his idea conceived of sending coded message, no, called Morse code this time. But I think Morse code this time is not so very useful, no. Okay, so that Morse code. But of course, Morse code having this code impulses, electrical impulses, or use these electrical impulses as a code, okay, to send message, no? So this was very known maybe in 17 in mga yung sa 19 parang ganon, no, mga 1980s, 1970s, no. Ito po yung ginagamit na communication system, okay, the Morse Code, okay, that even military this time is still using this Morse Code, but of course this is not widely used this time, no. And then we have this Charles de Coulomb. That Charles de Coulomb was the first person to measure the amount of electricity and magnetism. Because previously, maybe all those mentioned names were not be able to measure the amount of the electricity. But of course, they were be able to, or they found, they felt, or they determined, they specify electricity, but of course they do not know the amount, the exact amount of this electricity and magnetism. Here comes Charles de Coulomb. He was the first one who were able to measure the electricity, the amount of the electricity and magnetism. Okay, so that is why maybe because of this contribution, his family name Coulomb is used as the unit of charges. Okay, so that is the contribution of Charles de Coulomb. Okay, so we have in 1831. Okay, in 1831 we have James Prescott Joule, Gustav Robert Kirchhoffs, or some of the faculty pronounce this one as Kirchhoffs, but I used to pronounce this one as Kirchhoffs. Kirchhoff. Then James Clerk Maxwell developed mathematical relationship between electrical circuiting. Okay, so this was the contribution of these three persons, Joule, Kirchhoffs, and Maxwell's, no, or Maxwell. They were able to develop mathematical relationship in different electrical circuits. Then followed by George Simon Ohm. Okay, so George Simon Ohm formulated a law that discussed the relationship between voltage, the current, and the resistance. Okay, so George Simon Ohm tried to give relationship between the voltage, the current, and the resistance. That is why he was able to formulate a law, and of course he called this one as Ohm's Law, no? So it was formulated by George Simon Ohm, and tinatawag natin itong Ohm's Law. Ano ba itong Ohm's Law? It was or it is stated as the current is directly proportional to the voltage and inversely proportional to the resistance. So in other words, George Simon Ohm tried to give relationship between the voltage, the current, and the resistance. I will repeat. The Ohm's Law stated that it is the current is equal to or directly proportional to the voltage and inversely proportional to the current. Okay, so late 1800s, late 1800s, the ideal use of electricity was electric lighting. Okay, so yun ang pinakauna yung iniisip nila, na ginagamit lang po yung electricity for lighting. Okay, para of course to give light and better what do you call this one, lighting, no? Okay, so intensity of light, no? So it was late 1800. Then in 1860, okay, in 1860, there was an invention of the arc lights for lighting streets. Okay, so bali hindi lang po yung mga bahay o mga building yung uh, in-applyan ng lighting system, but of course including yung mga street lightings or yung mga daan. Okay, in 1879, okay, there was a development of this incandescent lamp by Thomas Edison. Okay, so Thomas Edison and Joseph Swan. Okay, so it was 1879. But of course, maybe the most famous person who invented that incandescent lamp was Thomas Edison. Okay, so yun na po yung pinakaunang lighting system or lighting device na ginagamit natin or bulb na ginagamit natin, yung na-invento ni Thomas Edison na incandescent bulb. Okay, so in end of 1880, there was a small electric station spread in the US area. So mayroon na po tayong maliit na production ng electricity. Okay, so it was a power station, can sustain only for a few city blocks, no? Yung maliliit lang na area yung masupplyan ng yung electricity kasi maliit lang yung na-produce nila. Okay, so yun po yung doon po nagsimula, no, diyan sa may sa United States of America. Then Edison's design is the basis in the distribution of electricity. There was a production of the direct current system, okay, and could not be economically transmitted over long distance. Why? Because if we have this direct current, anyway later on we will discuss about direct current, no? But just to give you an idea that if we are going to transmit direct current for a longer distance, then it will have greater losses o power loss. Okay, so in other words, malalaki yung mawawala dyan sa transmission system if you are going to use this direct current system. Okay, so in 1882, okay, we will be able to hear this General Electric, no? It is an electric company, okay? And ito po yung tinatawag nila noon na Edison Electric Company. Okay. And this General Electric demonstrated street lights and lamps in London and New York City. Okay, so ito po yung pinakauna na mga lugar na nabigyan ng mga lighting system, no? Mayroon na silang mga street lights. Okay. So ito po dahil sa General or GE, no? General Electric. In 1883, here comes Nikola Tesla, no? And he experimented, okay, or he experimenting generators. Okay, he experimented generators. How generator produce electricity. Okay, but before that, we also, or after that, no, we also, Lucien Gollard and John Dixon Gibbs, or G.D. Gibbs and Lucien Gollard, first introduced this what we call as a device that will step up or step down the voltage, or that even current, no, step up or step down the current. So meaning to say that they introduced this transformer which change, no, the amount of the voltage and or the amount of the current. This is especially used in or for transmission system. Okay, so George Westinghouse, Okay, in 1885, both Tesla's alternating current system. So the idea, the principle that Nikola Tesla was created or produced was continued or binili yun ni George Westinghouse, no? So yung tinatawag niya na EC system or alternating current system. And then it was the beginning of large scale electric power distribution. Okay, so from direct current converted to alternating current, and that alternating current can be able to transmitted for a longer distance, no? So until now, no, what we tried to transmit is not direct current, but of course, the alternating current. That is the current transmitted to a longer distance, and this time we made this what we call as grid. We have the Mindanao grid, Visayas grid, and the Luzon grid, no? So they tried now to interconnect all these grids. So this distribution system is only available if we will be using, or it can be done if we will be using alternating current system with the use of this transformer. And later, there was this commercialization of electric power. Okay, so yan po yung istorya, no? So in 1886, just to continue, operation of first alternating power station that is limited to lighting only. Okay? In 1888, alternating current motor was introduced and become commonly used in buildings, no? So saan po ginagamit yung mga alternating current motors? Yun pong nasabi ko kanina, it was used for the to power the elevator, the escalator, okay, and water pumps and other used. Okay, so alternating current is widely used, no? In 1930, US large cities had electricity, and 10% in rural areas had electricity also. In 1935, rural areas have electricity because of this called as rural electric administration. That here in the Philippines, we have this what we call as rural electrification administration. Okay, so we have this. It was established hundreds of electric cooperatives. Okay, so many years ago, it was the project of President Marcos to distribute electricity even in the very far rural areas. Okay? So, yun na po, mayroon na tayong mga cooperatives. But actually, it is not really using the principles of cooperative because all the members are just a consumer. Hindi po sila owner. If we will be talking about cooperative, we should be also an owner of these electric utilities. But we are not an owner. We don't have any other capital, no, given to them. But only we just consume. So we are not an owner, but we are just consumers. Okay? So that is in 1835. In 1935. In 1944, California legislated to deregulate electric power business in state, no, and established a competitive market. Okay, so this time they tried to establish a competitive market in the production of electricity or electrical power or electric power. In 1965, 1977 to 2003, okay, in United States and even in Canada, there was a failure in the power distribution, no? So until 2001, there is what we call as the bankruptcy of state utilities. So yun na po, kahit dito sa Mindanao, in 1985-86, mayroon na po tayong tinatawag na power crisis. Kaya nga mayroon na tayo ngayong we have this Pulangi 4. It was built because of the power crisis in 1980s, no? So this Napocor, I think, or as far as my memory is concerned, started its operation in 1986. Okay. And I hope that you learned many things with this chapter 1, the introductory portion of electricity, our subject, the theory of electricity. So thank you very much, and if you think that you learned many things, then try to subscribe my YouTube channel, so that if I have new video that will uploaded, then you will be notified. Subscribe, click the notification bell, so that you will be notified whenever I have new video that will be uploaded. Okay, thank you very much. God bless. Good day to everyone.